it's more than 50% of the American population that suffers from at least one chronic inflammatory diseases, so it's enormous. And so there is a large array of inflammatory diseases, whether it's arthritis, IBD, so Crohn's, colitis, cystic fibrosis is one. To some extent, cancer is also an inflammatory disease because cancer cells hijack the immune system. To drive the production of these inflammatory cells, the disease is going to produce a lot of messengers that are going to alert blood stem cells that are located in the bone marrow. And so as a response to these messengers, blood stem cells are going to increase the production of these inflammatory cells. And so it's really a positive feedback loop. So we've identified a dual mechanism. The first arm of that mechanism is the expression of a receptor, which we call a stress receptor. The second part of that mechanism is the activation of a gene that is going to remodel the structure of DNA, so that the remodeling of DNA structure is going to, on one hand, push for the promotion of inflammatory cell production, but also, very importantly, shut down the capacity of blood stem cells to produce the other cell types that it can produce normally, such as lymphocytes, for example. I think really what's new in that strategy is that we don't focus on the activity of these inflammatory cells, we focus on their production. It's just, if I can take an example, we don't try to destroy tank on the battlefield, we're just targeting the factory where the tank are produced. And so that's why we're coming with what we call a decoy drug conjugate. And so in that perspective, the decoy has two functions. The first one, as I've just said, is to inhibit that stress receptor, but the second function of that decoy is to serve as a docking site, to make sure that the second part, so that drug, only binds to cells of interest. And so that gives you an effect that is much more efficient than just putting two drugs independently, because they may not reach the same cell. Not only does that conjugate ensures that the same cell is targeted for both mechanisms, but it also limits the toxicity that the drug could have if it was not only targeted to the cell of interest. We still have a lot of work to do, but we're very excited by it. So I can't say it's 100% obviously, but I would come to the idea that this mechanism, that dual mechanism, is probably conserved across the board of inflammatory diseases. And obviously the consequences of that is that we think that the development of this asset could be a novel therapeutic strategy for a large range of inflammatory diseases.